So how do we deal with a string that has been cut or has gone slack? Well, if a string is cut, the tension in it is going to be 0. There's no tension force in it at all. Now that's quite important because it means the particle, if it's free to move vertically, so it's not sitting on a surface, it means it's going to accelerate downwards at g. Okay, this is just g. The reason for that is if I've got this particle on a string and the tension is 0, and here's the weight here, which is mg. When I write my equation of motion, I'm going to write W minus T is ma. That's my resultant force on the left, and ma is the other part of Newton's second law. The weight is mg, tension's 0, so I can just get rid of it. I get mg is ma, and my m's cancel out. So actually my acceleration is just g. Okay, so that means the particle is just going to accelerate towards the ground at 9.8 meters per second squared. That's only if the tension is 0, which is obviously going to happen if the string's cut. It's also going to happen if the string goes slack. What we mean by the string going slack is just that the tension in it has gone to 0. Once we know that, we can use Solve4x to find distances or velocities because we know the acceleration. If we know the initial velocity, we can find distances it travels and the final velocity and the time it takes to do things. We can find all sorts using Solve4x, which we did in the kinematics lessons, if you remember.